Today we are going to start our new topic, that is parallelogram law of vector addition. If a body is acted upon by two vectors which can be represented in magnitude and direction by two adjacent sides of a parallelogram drawn from a point, then the resultant is represented in magnitude and direction by the diagonal of parallelogram passing through the same point. That means if this is the point at which the two vectors are acting, such that one vector is this and another vector is this. We have said if two vectors are acted upon a body which represents the magnitude as well as direction of the two vectors, A vector and B vector, and if these two vectors represents the two adjacent sides of a parallelogram, then their resultant will be represented by the diagonal which lies in between them, and that diagonal will represent the magnitude and direction of the resultant. So we will make a parallelogram So if we complete this parallelogram and draw this diagonal R will represent the resultant of these two vectors A and B which are acting at this particular point. Now if we start naming these points, if this point is O, this point is P, this is N, this is K. Draw a perpendicular from this point meeting OP produced at point M. Now OPNK, this is a parallelogram, so the opposite sides are equal in magnitude as well as their direction is same. So we can write OP vector equal to KN vector equal to A. Similarly, OK vector magnitude equal to PN vector magnitude equal to B vector. So using this method, we apply So if we apply parallelogram's law of vector addition, then if R is the resultant, we can write it as ON vector equal to OP vector plus OK vector. Therefore, R vector equal to A vector plus B vector. So we can write down the resultant in vector form as a sum of A vector and B vector. Again I am repeating, if two vectors A vector and B vector are representing two sides of a parallelogram acting at a single point, then their resultant is represented by the diagonal which is in between these two vectors or two sides of the parallelogram. Now the expression for magnitude of resultant. So if A vector and B vector are acting at a point such that they represent the two adjacent sides of a parallelogram, then we will complete this parallelogram to find out the magnitude of the resultant. Now draw a perpendicular from this point. Meeting OP produced at point M. Say this angle is theta, so this angle will also be theta. If this side is A, then this will also become A and this will become B. This is K. Now the resultant is represented by the diagonal which lies in between these two adjacent sides, and that is represented by R vector. Now if we observe clearly the diagram, it is just like the diagram for triangles law. So we will use the same method as we have done earlier to find out the magnitude of the resultant. So in triangle OMN, ON square is equivalent to OM square plus MN square. We can break this OM as OP plus PM whole square plus MN square, and that can be written as OP square plus PM square plus 2OP into PM plus MN square. So we will give this equation as number 1. Now in triangle PMN, sine of the angle is equivalent to perpendicular upon hypotenuse, so MN upon PN, or we can say MN equal to PN sin theta, or PN equal to B, so B sin theta. Similarly, cos theta, in the same triangle, if we find out cos theta equal to base upon hypotenuse, so PM upon PN, or PN equal PM equal to B cos theta. So we will put these two results in the above equation number 1. Therefore, equation 1 becomes on equal to r, this becomes r square equal to op, that is equivalent to a, so this is a square plus pm equal to b cos theta, and we have to square it, so this becomes b square cos square theta plus 2 into op, 2 into op means a into pm equal to b cos theta plus mn square, so b square sine square theta. So we will combine these two factors and take b square as common, so this becomes a square plus b square cos square theta plus sine square theta plus 2ab cos theta. But the value of this trigonometric relation cos square theta plus sine square theta is equivalent to 1. Therefore, the relation becomes r square equal to a square plus b square into 1 plus 2ab cos of theta, or we can write as r equal to under the root a square plus b square plus 2ab cos of theta. So we have achieved the same result as we have achieved earlier in case of triangle's law, that is the magnitude of the resultant r equal to under the root a square plus b square plus 2ab cos of theta. Now we will derive an expression for the direction of this resultant, and for finding the direction of resultant, say this angle is beta, so we will find out the value of this angle beta, which this resultant makes with the horizontal direction. Now direction of r in triangle OMN, we will find out tangent of the angle. Tangent of beta is equivalent to, so this angle is beta, so this is perpendicular upon base, mn upon OM, but OM is equivalent to OP plus PM. So we will put the values of these quantities. Mn we have calculated earlier, Mn equal to b sin theta upon OP equal to a plus PM equal to b cos theta or we can say beta equal to, if we will take this tangent towards this side, this becomes tangent inverse b sin theta upon a plus b cos of theta. So by using this method we can easily calculate the direction of the resultant. Now special cases. Number first, if the angle between a vector and b vector is 0 degree, if theta equal to 0 degree, then r, we have calculated the general formula for resultant, a square plus b square plus 2ab cos of 0, and the value of cos 0 is 1, Therefore, the relation becomes a square plus b square plus 2ab into 1. But this becomes an identity, a plus b whole square, or r is equivalent to a plus b. So if the two vectors are acting parallel to each other and in the same direction, so the angle between them will be 0 degree and their resultant will be equivalent to r equal to a plus b. For direction of r, we will find out tangent beta equal to b sine of the angle. Angle is 0 degree upon a plus b cos 0. But sine 0 equal to 0. Therefore, tangent beta equal to 0 or beta equal to 0 degree. That means the resultant will also make an angle 0 degree with the horizontal direction. This is r. Now take second case, case number 2. If theta is 180 degree, so the resultant will become a square plus b square plus 2ab cos 180. But cos 180 is equivalent to minus 1. So the relation will become a square plus b square, and this minus will come in forward. So this becomes a square plus b square minus 2ab, and this becomes a minus b whole square, or this under root will disappear. So r becomes r equal to a minus b. So if the two vectors are acting opposite to each other, their resultant is represented by r equal to a minus b. Now for finding the direction of r, we will find out tangent beta by again using same method, b sine 180 upon a plus b cos 180. But sine 180 equal to 0, so therefore tangent beta will become 0, or beta will become 0 degree. Hence the resultant of these two vectors will be either in the direction of a vector or in the direction of b vector. We can take here two angles, beta equal to 180 also, depending upon whether a is greater or b is greater. Now in the last case, take theta as 90 degree. That means the angle between a vector and b vector is 90 degree. So we will put here theta as 90, so this becomes cos 90. R equal to a square plus b square plus 2ab cos 90. But cos 90 is equal to 0. So therefore the relation will become a square plus b square under the root. This is the final value of resultant. For direction, we will find out tangent beta. Tangent beta equal to b sine 90 upon a plus b cos 90. Sine 90 equal to 1. So therefore this becomes b into 1 upon a plus b into 0. Since cos 90 is 0, Therefore tangent beta equal to b upon a, or beta equal to tangent inverse b upon a. So by using this relation we can easily calculate the direction of the resultant that it makes with the horizontal direction. Now the next topic is Polygon's law. Of vector addition. Polygons. Poly means many. So if there are number of vectors, that is more than 2. If there are number of vectors acting in different directions, and we have to find out their resultant. Then we will use Polygon's law of vector addition. So according to this Polygon's law, if a body is acted upon by number of vectors which can be represented in magnitude and direction by the sides of an open polygon taken in order, this is very important, taken in order, then the resultant is represented in magnitude and direction by the closing side of the polygon taken in opposite order. So if we draw all these vectors such that they represent the sides of a polygon taken in order, we will not change the directions. This is A vector, B vector, C vector, D vector taken in order. Then the closing side of the polygon taken in opposite order, that will represent the resultant. Therefore we can write it as R vector equal to A vector plus B vector plus C vector plus D vector. So resultant is the sum of all the individual vectors acting on that body taken in order. The sides may vary. They may vary from 4 to 6, 5, 7, any number of sides can be there. But the closing side will represent the resultant, which is taken in the opposite order. Our new topic is subtraction of vectors. That means if we want to reduce one vector from another vector, consider there are two vectors, A vector and B vector, and we want to reduce B vector from A vector. So we can write as A vector minus B vector equal to A vector plus minus of B vector. So for reducing B vector from A vector, we will add minus of B into A. For reducing B vector from A vector, we will simply add negative of B vector to vector A, and we will get the result. So we can show this as in the form of diagram. If this is a vector and we place this b vector at the tip of a vector without changing the direction, if this is b vector, now we have to subtract this b vector from a vector, and for this we have to add negative of b vector. Now we can make negative of b vector by taking another vector just in opposite direction of the same size to that of b vector. This is minus of b vector. We name this as O P K, and this is M. Now PK vector equal to B vector. Similarly, PM vector equal to minus of B vector. This is the negative of B vector. Now, for finding the resultant of OP vector and PM vector, we will use parallelogram's law of vector addition, and for this we will just extend this OP in the forward direction in the same direction and of the same size. So this becomes PN, and that is also equivalent to A. Now we can easily apply parallelogram's law of vector addition for finding out the resultant. Now complete the parallelogram. So this point is T. So we will join this diagonal. So if Pn and Pm are the two vectors which represents the two sides of the parallelogram, then this Pt will represent their resultant. So initially, if this angle is theta, then the remaining angle is 180 minus theta. So the angle between A vector and minus of B vector, angle between A vector and minus of B vector is 180 minus theta. And for finding out the resultant, the magnitude of resultant, we will use parallelogram's law of vector addition. So R equal to under the root A square plus the another vector is this minus of B square plus 2AB cos of the angle between the two. The angle between the two is 180 minus theta. But cos 180 minus theta equal to minus of cos theta. So the relation becomes R equal to A square plus B square minus 2AB cos of theta. So this is the magnitude of resultant. R equal to A square plus B square minus 2ab cos of theta under the root. Now for finding out the direction of the resultant, if this is R, let it makes an angle beta with vector A. So for finding out direction, we always find out tangent of beta is equal to B sine of the angle is 180 minus theta upon A plus B cos 180 minus theta. So this becomes B sine theta upon A minus B cos theta. Sine 180 minus theta equal to sine theta, cos 180 minus theta equal to minus of cos theta, so minus sign will come in the front, and the relation becomes tangent beta equal to B sine theta upon A minus B cos of theta. So in this way we can easily subtract any vector from a given vector. Now our next topic is the properties of vector addition. Number 1, it is commutative in nature. That means if we add two vectors, say A vector plus B vector, then it will be equivalent to B vector plus A vector. This can be proved easily. Now if there are two vectors, A vector and B vector, representing two adjacent sides of a parallelogram, then the diagonal in between these two sides represents the resultant. So we will complete the parallelogram by joining Kn and Mn. Clearly OM becomes equal to Kn. Similarly OK becomes equal to Mn. So we can write it as A and this as B. Now in triangle OMN, OM vector plus MN vector equal to ON vector. We have studied in triangles law that if two sides represents the two sides of a triangle taken in order, then the third side will represent the resultant. So this becomes A vector plus B vector equal to R vector. Number 1. Similarly in triangle OKN, OK vector plus Kn vector is equivalent to ON vector, that is B vector plus A vector equal to R vector. This is equation number 2. So if we compare these two equations from 1 and 2, it is clear A vector plus B vector equal to B vector plus A vector. So this proves the commutative property of vectors addition. Now another property of vector addition is it is associative in nature. That is, if there are three vectors, A vector plus B vector plus C vector, we can write them as A plus B vector plus C vector. Now we can prove these identities by taking an example. Now consider these three vectors shown in the diagram. Completing this diagram, now in triangle MNK, triangle MNK, now we can easily write Mn plus Nk equal to Mk. So Mn is equivalent to B and this is equivalent to C. So B vector plus C vector equal to Mk vector. This is equation number 1. Similarly, in triangle OMK, OMK, OM vector plus MK vector equal to OK vector. This is the number 2 equation. So we can put the value of Mk from equation 1 in equation number 2. Put 2 in 1. Therefore, OM equal to A vector plus Mk equal to B vector plus C vector. So B vector plus C vector. This is the value of Mk and this is equivalent to OK vector. Equation number 3. Now take another case in triangle OMN, triangle OMN, OM plus MN equal to ON. So this becomes A vector plus B vector equal to ON vector. Equation number 4. Now take another triangle. In triangle ONK, ONK, ON vector plus NK vector equal to OK vector. This is equation number 5. So we will put equation number 4 in equation number 5. Put 4 in 5. The value of ON vector is equivalent to A plus B vector. A plus B vector plus NK vector. NK vector equal to C vector and sum of all these vectors is equivalent to OK vector. This is equation number 6. So if we compare equation number 6 and equation number 3, from third equation and sixth equation, it is clear that A vector plus B vector and C vector is equal to the sum of A plus B vector plus C vector. So this proves the identity that vector addition is associative in nature. In comparison to vector addition, if we take vector subtraction, it does not follow the law of associative nature as well as commutative nature. So the vector subtraction it do not follow commutative law. Commutative law, that is a vector plus b vector is not equal to b vector plus, not plus, a vector minus b vector is not equal to b vector minus a vector. That can be proved as we have proved in case of vector addition. Similarly, it do not follow associative law. Number 2, do not